Today we are going to start with the networking. What do you mean by network? Network is all about connecting two or more devices. Fine. Then what do you mean by networking? So difference between the network and networking. So networking is connection of two or more devices. Then what do you mean by networking? So processing and creating and configuring the things, even that can be comes under networking. Okay. And along with that, so network is all about connection of two or more devices, whereas networking is all about connecting two or more networks. Connecting two different networks can also comes under networking. And along with that, even say processing or configuring or creating or connecting the devices within the network, even these things comes under the networking. Okay, let us assume here we are having the two devices. So consider it as the device 1 and this is the device 2. Now, what are the things we require to create the network? First thing, what we require is some medium of connection, like we can say LAN cable. So here I am using the LAN cable to connect one device with another device. Okay, so now I have the LAN cable. Let us assume IP address. So here I am going to provide the IP address as 192.168.2.20, and now I am going to give 192.168.3.20. So now you tell me, is it okay to create the network? So whether the communication will be established or not?
They can't communicate with each other because of different IP address.
Okay, can you tell me what is the correct way to give the IP address?
The first three should be same and the host may be different.
Okay, let us assume.
The last,
Here I am
yeah.
changing it to the 3. This is what you mean to say.
And the last 20 is there, no, that may be different.
So one is 20 and the other one is 21 or 22. Now, is it possible to create the communication between the two devices? It is possible. But can you tell me what if I give one is 2 and the other one is 3? Why it is not able to communicate with each other? Here we are having two different networks. If I give one is 2 and the other one is 3 now, these things are like two different networks. So that is the reason
Yeah.
it is not possible to communicate. Let's say now I want to communicate with you. Okay, two people want to communicate with each other. Okay, here further the medium of communication will be the language, whatever we are speaking. So language can be the medium of communication. Now let us assume you know French and I know Spanish. I was talking something and you were talking something. Can we able to receive what we are saying? Can we able to create the communication between you and me? So definitely it is not possible because I don't understand French and you don't understand the Spanish. So that is the reason no matter how much packets you send, packets is nothing but how much you speak. Okay, here whatever we are speaking that can be called as the packets. You were unable to receive and even I was unable to receive. So that is the reason the connection between you and me will not be able to established. So in the same way, if two devices were in the two different networks, no matter how they were trying to communicate with each other, it is not possible. The packets will get dropped. Even though how much information was being sent from one device to another device, it is not possible to receive each other. So for that, we should know the same language. So you know English and I know English, so definitely we can able to communicate. So you will understand. You will take my request, and even you will respond as per my request. And even I can take your request, and even I can respond as per your request. So the communication between both of us can be established because we are configuring the same network. Okay, we are using the same language. So in the same way, in the network also, two devices should be connected to the same network. Here, first three digits can be called as a network ID and the last digit can be called as the host ID. If the network ID is same now, definitely both the devices can able to communicate with each other. And one more thing, we cannot able to give the same IP address to the two different devices in the single network. It is not possible. Definitely, it is not possible. Each and every device will have the unique IP address in a single network. This is how we can able to create the network. Now, I have the LAN cable, so I am having the one NSA Ethernet port, network interface code. So I have connected one end to my laptop and another end to another laptop. So it was connected. So, okay, let us assume I have given the another IP address in the same network considered as the device tree. Either we can use the switch or hub or router, or else we can go wireless. Okay, these things can be called as a network device. with the help of the network device, I can able to connect two or more devices. Okay, so this thing can be called as a access point. Now consider as a network device. Either it might be a switch or hub or router, anything it may be. Okay, I'm going to call it as a access point. Okay,
Okay.
here in this scenario, we will assume it as the switch. Okay. So using the network devices, we can able to connect a number of devices through wired. Okay. Or else even we can able to connect them wireless. Okay. This is how we are going to create the network. Now coming to the network devices. So what is the difference between the hub and switch? We are going to make use of the hub where we can able to connect multiple devices, right? We can call it as a non-intelligent device. Whereas switch, we can call it as a intelligent device. So the reason why we are calling hub as a non-intelligent device is in the hub, whatever the information, like how many devices you are connected, so whatever the information you share, that information will be shared to each and everyone. Here, if you observe, so this is the hub. Hub and switch both look alike. Okay. Here you can see you are having multiple ports at the back of the device where each device can be connected with the cables. Okay, each port will be assigned to the each device. Here if you observe there are 8 devices that are connected to the hub. Now if you observe the device 1 is sending the information. Okay, this red color dot can be called as the information. Now if you observe that information was splitted and received by the each and every device that is connected to the hub. Here device 1 is sharing, consider device 1 wants to send the information to the device 5. Okay, but here rather than device 5 the information was being sent to all other devices connected to the hub. So here the privacy is not maintained in the hub. So even though if there is any confidential information is there now, everything will be received by all the devices. So that is one drawback we are having in the hub. And along with that, if device 1 is trying to communicate with the device 5, and during that time device 7 wants to communicate with the device 2. Okay, now device 7 is also sending the request at a time. When device 1 is sending now, even device 7 is also sending the information at a time. If both the information was sent at a time now, in the hub there might be chance of happening the data collision. Let's say consider there is a one way, okay, one way road, and vehicles should
Okay.
be traveled in one direction only. Okay, now at the same time there is a vehicle which is approaching from the opposite end. So what will happen? Accident. So both the vehicles can get collide each other where it leads to the collision of the vehicles and it leads to the accident, right? In the same way, if two devices are trying to communicate at a time, so even in the hub also, all the data will be shared from the same port. Okay, same port. So if both are sending at the same time, so then the data might get collide each other, and there is a chance of happening the data collision. That is a second drawback that we are having in the hub. These are the two drawbacks that we are having in the hub. So that is the reason later we have shifted to the switch. Now coming to the switch, even switch also looks like the hub only. So as you can see here, in the switch also you will be having the ports at the back end and different devices were connected to this switch. Okay. So you can see different devices were connected to this switch. Okay. In this switch, what it is happening is like why we are calling switch as the intelligent device is, so here in this switch, whenever a device is connected to the particular port now, so the device related information will be stored into the CAM table or the MAC table. Okay, the device related MAC address and the IP address will be stored into the MAC table. Okay, so that the switch will be having the information about the each and every device. So whenever the device is trying to communicate with the another device, so now switch will be having the source related information and the destination related information. So the switch can see, okay, from which device the request is coming and to whom it should be sent. Then the switch is going to check for the address that was there in the stored in the MAC address table. Then the switch will understand, okay, device A wants to communicate with the device C. So this is the address of the device C and this is the address of the device C. So based upon that, the request will be sent to the receiver, from the sender to the receiver in the switch. And one more thing, if two devices want to communicate at a time, like if two devices are sending the request at a time in the switch now, so for each and every device there will be a separate port where there is no place for the data collision. here we can able to overcome from these two kind of scenarios. So privacy is maintained and data collision is not being taken place. So that is the reason we are using the switches. Whereas in the hub, we don't have the MAC address table. So the hub don't know who is the sender and who is the receiver, what is the source address and what is the destination address. So that is the reason we are calling it as the non-intelligent device, whereas switch we are going to call as the intelligent device. Okay. Now, where the address is being stored over here in the switch, we told like
Uh,
the address will be stored into the MAC address table, right? But who is the responsible
yeah.
for storing this information? The information will be stored because of the protocol called ARP. So ARP stands for Address Resolution Protocol. So this protocol will help us to store the information, I mean the addresses of the devices that are connected to the network. So how it will be stored, I will show you. So if you open the command prompt and if you type ARP space hyphen ARP stands for Address Resolution Protocol and hyphen A, and if you hit on enter, you can see the addresses of the devices. Okay, this is how it was stored into the MAC address tables. Okay, so actually this is how the ARP will store the information of the device. So here IP address and MAC address. So this is how it will be stored in the backend. So physical address can also be called as the MAC address or permanent address. Okay, now coming to the router, even router is useful for us to connect the multiple devices. So in the router we can connect the devices either wireless or wired. Okay, so even router will be helpful for us to connect the multiple devices. On backside of the router, you will be having the port same like for the switch and hub, right? So when you're connected with the LAN cable, even your device will get the internet connection. That is fine. But the main purpose of the routers is the routers are going to define the shortest path of the destination from your network. It is going to find the shortest path for you to reach your destination, and based upon that you can able to connect with the your receiver. Okay, let's say you want to access to the racequad.world website. Okay, so the router is going to find the shortest path from your network address to the server address, and from there it is making you to connect from the device. Okay, so if you want to find how you are connecting with the server now, you can make use of the command called traceroute. Okay, traceroute is for Linux and for Windows it is tracert, TRACERT. Hit on enter, so it is going to give you the information. You can see the IP address of the domain name, that is racequad.world, and then after it is going to give you the maximum of 30 hops. That means, see, whenever you are trying to communicate with the server now, like your destination, if it is more than 30 devices were involved in between you and the destination, so it is not going to give those related information. It is going to give the first 30 devices related information. Okay, if you are getting these star marks in between now, so there we can say they were using the firewalls over there. Those information were filtered. Okay, so it can give the information about up to 30 devices. Okay, and this is the shortest path for me to reach to my destination. So this path will be defined by the routers. This is the main functionality of the routers. Okay, there are many other functionalities we have with the routers, but this is the main functionality. So to get the details of the network path from your device to your destination now, so you can use the command tracer command in Windows. If it is Linux, you can use traceroute. Okay, and here you can see a terminology called hops, right? Actually hop means, let's say here I am typing something. Okay, now my traffic will be sent from my device to my router first, then that can be called as one hop.
Yes.
Then after my router to the ISP, the internet service provider, then we can say that is a hop. So whenever the traffic changes from one network device to another network device, a hop is created. Okay, here total 13 hops were involved in between for me to reach my destination. Okay, so this is how we can able to trace the route of the destination as well. Okay, now coming back to our session, we have seen that IP address is mandatory for us to communicate with the network, right? To create the network, right? Now coming to the IP address, so IP address can be called as the identity of the device. Okay, so consider a house. Okay, now if you want to send a post or any parcel to the house, how can you able to send it to that particular address? By using the door number or the house number is the identity of that particular house, which is allotted by the government. So how the house number is going to specify this is the identity of the house. In the same way, we can able to the IP address can able to identify the device. So this IP belongs to so and so device. Okay. Coming to the MAC address. So MAC address can be called as the physical address or the permanent address, right? Which will not be changed. It remains same every time. Let's
Yes.
say there is a house and you are sending the parcel or some courier or some post to a person. Okay. So for that also you will be adding the house number or the door number, right? Nothing but the IP address. So within that home, there might be many people like father, mother, brother, and sister. So there are different peoples, right? If you want to send it to the particular person, then you will be mentioning the name of the person, right? Now within that house, Shanthan is a single person and we cannot able to change that name. So that name will be permanent. So that can be considered as a MAC address. Here, the IP address is the identity of the device and MAC address can be the physical address or the permanent address, which will never changes. Okay, it will remain same. In the IP address, we are having the different versions, IPv4 and IPv6. These are the two different versions we are having in the IP address. Okay, IPv4 is a 32-bit length IP address and where it is having 4 octets. Okay, and it is a combination of decimal values. For example, we can say 192.168.0.1. Okay, whereas IPv6 is 128-bit length and where it is a combination of alphabets and numbers. Alphabets from A to F and numbers from 0 to 9. So this is the range of the IPv6 IP address, whereas coming to the IPv4, the range is from 0 to 255, which means from 0.0.0.0 to 255.255.255.255. So this is the
Okay.
difference between the IPv4 and IPv6. Actually, IPv4 with the IPv4 only we can connect maximum devices like more than some crores of devices we can able to connect using the IPv4 IP address. But in future, anyhow, at some extent, so we may finish all the IPv4 IP addresses. So as a backup, we should have some plan where we can able to connect more than those devices as well. So based upon that, because of that reason, even we have implemented the IPv6 IP addresses where we can able to connect some millions and billions of devices with the IPv6. Okay, and even you can see the bit length that is 32 and this is 128 where we can able to connect maximum devices which is not limited. Okay, still we are using the IPv4. The range is not at all finished. Again, we are having the IPv6 as well. That is the main purpose for implementing the IPv6. The example for the IPv4 IP address is, so this is the example IP address of the IPv4. So now if you observe here, IPv4 is the decimal. If you observe, only numbers were there which are separated by the dots. 192.168.0.1, whereas IPv6 I told you na hexadecimal value. It is a combination of alphabets and numbers. If you observe here, 2606 4700 3037 colon 6815 5A63. If you observe, there is a alphabet A as well. So it is not mandatory to have the alphabets and numbers for sure. It is not mandatory, but it may have alphabets and numbers, or it may have only numbers, or it may have only alphabets. Okay, but it is a combination of alphabets and numbers. Okay, so if you observe here, you are having the columns and colon, right? So what does it
Yeah.
mean is like, in case if you are having 0000 colon 0000, or even if you are having colon 0000, so whatever it is, if you are having zero zeros next to it, okay, continuously one after one, then we are going to represent this entire information with colon colon, which means in between we are having all zeros. Okay, actually this is the exact one. Okay, this is the exact one.
Okay,
Since
okay,
I
I
am
understood
having
now.
zeros
Yeah.
next to it now, this is
Mm.
how we are representing it. Okay, so this is the major difference between the IPv4 and IPv6, and why we call this IPv4 is secure is like, see, 192.168.0.1, it is very easy for us to remember. Yes or no? Is it easy for you to remember this IP address? It's difficult. And even if you are having more alphabets in between, it will become more difficult, right? So
Yeah.
that is the reason people call IPv6 as the more secure when compared to IPv4. So here we are completely focusing on the IPv4 only, because in general we are using the IPv4 IP address only. Yes or no? So why we are calling it as a 32-bit length is like, so this 192.168.0.1 IP was in the form of human readable language, right? This is understandable by the humans, by us. But whether the systems will understand the same thing or not, they will understand the binary language, which is nothing but zeros and ones, right? So whenever you convert this IP address into binary, you will be getting the 32-bit length, okay? So zeros
Okay.
and ones. Even this can be called as the bits. Okay, let us say how to convert the IP address to the binary. Here, what we can do is like, so we are going to note down the numbers from 2 power 0 to 2 power 7, okay? So 2 power 0 from right to left, okay? So now whenever you note down the numbers now, if you take the numbers from left to right, no, 2 power 0 is 1. So now my IP address is 192. So what I'm going to do is like, I'm going to convert this value into the binary, okay? So please listen carefully. Now
Okay.
further what I'm going to do is like, I'm going to add 2 power 7 and 2 power 6, okay? So the value of 2 power 7 is 128, 128 plus 64, okay? So the value is 192. Adding 128 plus 64 is 192. So here I am using the 2 power 7 value, there I am placing 1, and along with that I am using 2 power 6 value. Even here I am placing 1, okay? And remaining places, if I add 32 to 192 now, it will become more than 192, which is not recommended for
Yes.
me. So I am not making use
Yeah.
of 2 power 5, and I am not making use of 2 power 4, and even I am not making use of 2 power 3, and I am not making use of 2 power 2 or 2 power 1, and even 2 power 0. So I'm not making use of any of these values except 2 power 7 and 2 power 6. So now the binary value of the 192 is, it's 11000000. This is the binary value of 192. Okay. The next one 168, right? Now could you mind telling me what is the binary value of 168? So first we will add with 2 power
Yeah,
7
well,
and 2 power 6. Okay. So 2 power 7 is 128, which is less than 168, right? So again
yeah.
I am making one here because I am adding 2 power 7. And then
Yes.
after I am going to make use of 2 power 6. So adding 128 plus 64 makes 192, which is greater than
Yeah.
168. So I'm not going to use 2 power 6. I'm leaving it, okay? So I'm adding 0 at this place. Now what I'm going to do is like, I'm going to add 2 power 5. So 2 power 5 is 128 plus 32. It's 160. So I'm going to make use of this as well. So here I'm going to use 1. So 160 plus 2 power 4 means 16. 160 plus 16 is
Yeah.
176, which is greater than 168. So I'm not using this.
Yeah.
Okay. Then after 2 power 3.
This one you can use
160
like
plus 8.
one
Here it is 1. And rest all are
zeros.
zeros. Because I got my value, so I can make other things as 0. So the binary value of 168 is 10101000. The
Yes.
binary value of 0 is 0
All zeros.
0 0 0 0 0 0 0, right? And what is the binary value for what?
One is all zeros. Last one is one.
So for one is, so I hope you understood how to convert the decimal value to the binary, right? IP address to
Yes.
binary value. So the binary value of the 192.168.0.1 is 11000000 dot 10101010 dot 00000000 dot 00000001. This is the value. Now if you add these values, so this is 8, 8 plus 8 16, 16 plus 8 24, 24 plus 8 32. That is the reason we call it as the 32 bit. So zeros and ones can be called as the bits, right? So and then after we said it was having 4 octets. So 8 digits means 8 can be called as the octet, right? 1 2 3 4. Everything got satisfied, right? As we said, the range is from 0 to 255, right? Now if you
Yeah.
observe, for 0 we are having 000000, right? It was satisfied. Now the final digit we will count. So what is the value of 128 plus 64?
Oh, it's 192.
So 192 plus 32. 224. 224 plus 16, 240 plus 8. So 248 plus
240.
4. So 252 plus 2, 254 plus 1.
255. Now we
So
got.
255,
Okay.
right? So total by adding all
Yeah.
these values, you are going to get the value as 255.
255. Range.
So that is the
That means
reason
the
we
range is
told
also test
the
satisfied
range.
here, right?
Yes, 0 to 255. So till we can get 0.0.02, 255.255.255.255, right? Everything got satisfied,
Yes.
yes or no? This is the difference between the IPv4 and IPv6 and how we can convert the IP address to the binary format and how why we are calling it as a 32-bit and the range is 0 to 255. Everything got satisfied, right? Even MAC is a combination of alphabets numbers, so even it is a hexadecimal value. Numbers and alphabets, the range of the numbers is from 0 to 9 and alphabet is from A to F. This is the example of the MAC address. Yeah, you can see alphabets and numbers both are there over here. If you find any alphabet rather than A to F like G, H, I, J, something like that, that can be called as the fake MAC address. Even in the IPv6 also, you will be having A to F only. If you can see any other alphabet rather than A to F now, that can be called as the fake IP address. Okay. The MAC address earlier, the bit length of the MAC address is 32-bit. Okay. But now we are having the MAC address as the 48-bit length. So why we are having the 48-bit in the latest MAC addresses is nowadays, if you observe, each and every device is having the option called MAC randomization. Okay, here in the network settings, you are having some
Yes, we
option
can
called
see.
random hardware address, right? It was turned off. Okay. So if you turn this on now, what it is going to do is like for some certain time interval, let's say for every 15 minutes or for every 20 minutes, it is going to change my MAC address randomly so that it will become harder for the people to track my location or the device identity, which helps me to protect my privacy and my information. Okay. So for that reason, they have given the option called MAC random hardware address. Okay. So this can be called as a random MAC randomization or random MAC address. Okay. Actually, since it was assigning multiple MAC addresses to our device, for that it needs more space, right? So for that, we are having the 48-bit length. So it was changed from the 32-bit length to the 48-bit length. Earlier, we don't have this random hardware address option. So at that time, our MAC address was 32-bit length for the old one. In the latest one, we are having the 48-bit length where it is useful for us to assign the random MAC addresses, which helps us to protect our privacy. And in this MAC address also, here, the first 6 digits is going to specify the details of the vendor, like the manufacturer details, and next 6 digits is going to showcase the address of the device. Okay, MAC address is the address related to the hardware, right? Each and every hardware device will have the MAC address, like the interfaces like the Ethernet cord, Bluetooth, or Wi-Fi adapter, or the virtual adapter, or external Wi-Fi adapter. In case if you are having the RFID or NFC, so for these kind of interfaces, you will be having the different MAC addresses. Okay, let me show you
Okay.
how to identify the MAC address of the device. Okay, so we should open the command prompt, and in the command prompt, if you type the command get MAC, okay, get MAC, and if you hit on enter, it is going to display the MAC addresses. Here it is assigning team showing 3 MAC addresses, but we don't know to whom this MAC address belongs to, for which interface it belongs to, right? So for that, if you use getMAC hyphen v, getMAC space hyphen v, and if you hit on enter, it is going to showcase clearly like Wi-Fi. For Wi-Fi, this is the MAC address, and for Ethernet, this is the MAC address, and for virtual box, so this is a different MAC address. Okay. So as I told you, first 6 digits are going to specify the vendor related information. No? So I hope you understood how to check the MAC address, right? So now if you go to the browser and if you search for MAC vendor in the browser
Yes.
now, if you hit on enter, the first link macvendors.com. Okay. If you hit on this first link, so it is going to ask you to enter the MAC address. Here I am going to paste the MAC address. So if you observe, here it is going to give the information of that MAC address, internal corporate. Okay. And it is not mandated to provide the
Okay.
entire information. Even you can give the first 6 digits. Okay. So here I'm going to give my Ethernet related information 0000 D8 and 61. Even it is not mandatory to add the columns or anything, it will give the information. You can see Microstar International. Actually, my laptop is MSI, which stands for the Microstar International, developed or manufactured my Ethernet port. Okay, so you can see here. So 00 D861, right? So this is the information I have given over there, which is related to my Ethernet. So this kind of information is very much useful during the forensic analysis for investigation purpose.